All right, let's talk about thermal physics. So now, you know the word therm. Anytime you hear the word therm, what does it refer to? Heat. Is that okay? So in biology, we hear ectotherm, poikilotherms, endotherms. Is that okay? Just like when you hear bar, what does it refer to? Pressure. Do you get it now? Pressure refers to, I mean, bar refers to pressure. Okay. Now, if now I want to talk about thermal physics. It's the aspect that studies heat changes and all of that. Now, what about heat and temperature? So, do you know there is a difference between heat and temperature? Okay, what do you think is different? Eh, so, does it mean that heat is measurable? Okay, now right. Heat is defined. Heat is defined as the total internal energy. Heat is defined as the total internal energy. The total internal energy of a system. Internal energy of a system or a molecule or an atom, depending on what we're talking about. Is that okay? The total internal energy. That is what heat is, the total energy of a system. That's what heat is. Now, this is now temperature. Temperature is the degree of hotness or coldness of a system or a body or atom or molecule. But you see, in terms of what it is, because if you say the degree of hotness or coldness, I mean, that does not really explain its relationship with heat energy. I hope you know. That does not really explain its relationship. So, how do we define temperature in terms of energy too? You notice we said that heat is what? Total internal energy of a system. Now, what is temperature? First, temperature is our perception of heat. What did I say? Is our perception. So how do we perceive heat? We perceive it as temperature. What did I say? As temperature. Now, temperature is actually the a measure, right? Temperature is a measure of the kinetic energy of a system. Are you getting it? Temperature is what? Is a measure of the kinetic energy of the molecules of a system. Now, so this is so every system is made up of every atom is made every matter is made up of atoms, right? And these atoms are bound together. Now, do you know that these atoms are actually vibrating? Yes, it's not visible on the very micro scale, the microscopic scale. It is actually vibrating. So you see the atoms of this thing. If I zoom into this thing like a millionth time, that is the micro scale. Now you're going to have this molecule. You are going to see the structure, the carbons. This carbon, poly, this plastic, right? Polyethylene family. So we have this guy, this guy, this guy. I mean, they can come in different shape and all. So now, you see these guys, as they are bound together like this, they are vibrating. And those vibration is actually kinetic energy. Do you understand? So they are vibrating with themselves. And if it is a case of liquid and gas, they will be vibrating with the wall of the container. Is that okay? So think of this bond between them, this bond there. Think of it as it were a spring. So they are vibrating at around the locus of that spring. They are not going. That spring is fix them to a point, but of course they are vibrating about that fixed point. Do you understand? And there are different types of movements actually, but those of solid they are vibrating about a fixed point, but still they are doing what? they're vibrating. So when you increase the internal energy, kinetic energy of this thing, what you have done is what? You have increased their temperature. How? Because it is that average kinetic energy. This is what this way it is. As you set these two in motion, when these two are in motion, they will transfer that kinetic energy upon them. They will transfer it to the next molecule and to the next molecule and to the next molecule and on and on like that because it's a spring system, right? So they will be transferring the energy until everybody begins to what? To vibrate. And the moment everybody begins to vibrate, the kinetic energy has what? Increased. I mean, as it is being passed on to them, the kinetic energy is increasing and we will now be perceiving that increase in kinetic energy as what? Temperature, degree of hotness or what? Or coldness. So for example, let me give you two systems now. Look at this system containing gas, filled with gas, or water. Let's ever use water. So this guy is filled with water, this guy is filled with water. Now, if this guy is cold water, let's say this was ice cold, this was hot. This ice cold water is at a lower temperature, yeah? This hot water is at a high temperature. That's what we perceive. But actually, what is happening is that this hot guy has a higher kinetic energy. The molecules of this guy, the water molecules here, they have a higher kinetic energy than the molecules of water. The molecules of ice here, rather, are more relaxed. Do you understand? Albeit they are still vibrating, but very little. Do you understand? The vibration is very minute. But unlike these guys, the vibration is what? Very high. Now, what do you do? If you put fire here, set fire under this guy, and it begins to burn this guy, heat up this guy. What will happen is that the molecules here will vibrate. They will vibrate so fast. They will pass on that vibration to the next layer. Those ones who will vibrate, they will pass it on like that. And that is why that temperature is, we tell you, is that heat transfer is by convection. Do you understand? So what happens is this, the higher the kinetic energy of that system, of a substance, usually, the lighter it becomes, in a way. Do you understand? So what happens is, the heavy water is the one that is down here. Is that okay? So as you heat this place, that heavy water will have gained enough kinetic energy. What does it do? It moves up. So as it's moving up, it's allowing the other guy, the other layer, to come down and become heated, thereby transferring that kinetic energy that it has gotten to those ones that are next to it, and the next layer again, like that until the entire system becomes hot. Do you understand? So that is why when you see that, it will get to a point that this system can no longer hold that thing again. What will they begin to do? Escape as vapor. Do you understand? They begin to evaporate. So that is what heat. That is the difference between heat and temperature. Okay, let's now talk about more difference. Talk about more difference between them. Talk about more difference. Now let's talk about heat here and temperature. Now for heat, we said is internal energy. So it is a form of energy, right? It is a form of energy, and in fact, it is the most measurable form of energy because it is quite harder to measure things like chemical energy, light energy. It is hard to measure them. So the most measurable form of energy is what? Heat energy. So it is a form of energy. It is a form of energy. So if it's a form of energy, while this guy is just a fundamental quantity. I hope you know it's fundamental. Or you say physical quantity. Those are physical quantities. But heat is an energy. So what that means is this. When I say physical quantity, what that means is that when you call something physical quantity, it means that you can see it physically, right? You can perceive it physically. Unlike heat, this board now, do you know if it's hot or not? Even when you touch it, you think, if I told you it has hard energy, now you're not able to tell, right? Or you just assume because you're a physicist. But how do you perceive? So temperature is the one you now what? Perceive. So if you now touch it and see it's hot, you now say, okay, it has high, so the kinetic energy is what? Is high. Do you understand? Of the molecules that make it up. Alright, so what's the unit of heat, of energy? Joules. We said it was named after James Prescott Joules. Do you get it? So that's the unit of heat energy. What's the unit of temperature? Kelvin. That's the SI unit. But in other countries, they use things like Celsius, degrees Celsius. They use Fahrenheit. Now Fahrenheit is one that is commonly used in United States, America. Is that okay? So, but SI unit generally all over the world is Kelvin. Now Celsius. Now I'll tell you why. You did not even ask why it is Fahrenheit, it is Kelvin that is being used all over the world, or like is the SI unit. Yeah, it's simple. The reason is because Kelvin is the only scale that provides the idea of absolute temperature, absolute zero. We call it the zeroth temperature. Do you understand? It is the only scale that gives us a zero value for, we call it the absolute zero value, zero, absolute zero temperature. If there is absolute zero, it means that no temperature at all, right? And if there is no temperature at all, it means what? No kinetic energy, right? Good. So, and it is possible for something not to have energy at all, isn't it? So if that thing does not have energy at all, it means that it is at its absolute zero temperature. Do you understand? So one of the reasons why we use it because of is one that makes provision for absolute zero temperature. So for example, if something is at 0 degrees Celsius, it's not still at the absolute zero temperature. Does that make sense to you? The absolute zero temperature is minus 273 Kelvin. So what we are going to be doing in this session is we are going to be converting between those units. Is that okay? But let's talk more about their differences. What other thing do you see differentiates them? Heat is, we said, both of them are scalars. Is that okay? Both of them are scalar quantities because it's energy is scalar, temperature is scalar. Now, the other thing that we can mention about them, okay, don't worry, when I remember any other thing, I will let you know. So let's go on to what are the effects of heat? The effects of heat. So it causes expansion to occur. It causes burning sensation. Okay. Yes, yes. Thermionic effect. You know thermionic effect? When substances absorb heat, they begin to emit ions. That's why it's called thermionic effect. We'll be studying that under how solar works, solar panel, how it works. We're going to be talking about that thermionic effect. So yeah, melting and boiling, those are the effects of temperature. Now another thing is change of state. Change of state, that's exactly what you meant there. Because ice will change to water if you boil it. If you heat it and then you heat it to a point it begins to boil. Is that okay? Right. Now let's talk about the conversion. So we said we have three scales. We have Kelvin, is denoted by K, right? The Celsius. Another name for Celsius scale is centigrade. Is that, do you know why it's called centigrade? The name of that guy is under Celsius. But centigrade, because it's using what centi? 100. Do you understand now? So centigrade, 100 grade. That's why so in a thermometer we have 2 points. We call them the fixed points. Fixed points. A thermometer has what? Two fixed points. Now there's a point up here and there's a point down here. This one is called the upper fixed point, and then it's called the lower fixed point. Does that make sense? I want to teach you how to use this to calculate even the conversion, and that's where we'll start from. Then I'll now give you formulas. Formula is easier. Is that okay? Because, oh no, it's not easier, it's faster. It's faster. Alright, so this is upper fixed point. The difference between them, so for this Celsius, it uses from 0 to 100 granote, 100 degrees. Do you get it? So that's why it's called the centigrade. So the interval between the difference between the lower fixed point and the upper fixed point is called the fundamental interval. What do I call it? Fundamental interval. Alright, so now, what do we do? What did we say about that? Celsius is degree Celsius. Now, how do we convert? Then we also have Fahrenheit. Fahrenheit. It's quite high and hard to spell. So degree Fahrenheit, is that okay? These are the two that use degree, that uses degree. This one does not use degree, is that okay? So if I want to go from Celsius, degree Celsius to degree to Kelvin, it's simple. What I just do is I add 273 to that degree Celsius. Do you get it? All right. But what if I want to go from degree Celsius to degree Fahrenheit? It's simple. We say 9 over 5. It's simple to know. Okay, you can cram this, but there's a way I master it too. I just don't. Like if you ask me to, for example, if you ask me to say it now, this is what I used to remember it. I will just ask myself, I'm going to Fahrenheit. You see that I would not. Right now, I can't remember how to go from degree Fahrenheit to degree Celsius. But look at what I will do. I'm going to now use this as subject of formula. I will change subject of formula. Is that okay? So I'm going from degree Celsius to Fahrenheit. So degree Fahrenheit will give me 9 over 5 of degree Celsius plus 32. Does that make sense to you? Now, if I make degree Fahrenheit subject here, so what I do is this. Degree Celsius, I want to make it subject here. So what will happen is F minus 32, right? So F minus 32, then we'll now multiply both sides by 5 over 9. So multiply here by 5 over 9. Does that make sense to you? So this is so to go from degree Fahrenheit to degree Celsius, that will be F minus 32, 5 over 9. And to go from degree Celsius to degree Fahrenheit, we will have 9 over 5 degrees Celsius plus 32. Does that make sense? Do you understand? All right, let's solve some questions. It's possible to go from Celsius and Fahrenheit to Kelvin, so, but it's in steps. Let me show you how we derive that formula in case you are lost. First, the centigrade scale. We said it has two fixed points, 100, 0, right? Why the Fahrenheit scale? So the fundamental interval is 100, right? For Fahrenheit scale, is from 212 granules. It's from 32 granules to 212 granules. So the fundamental interval is what? 180 degrees. Do you understand? So that's where we got this 32 from. Do you get it? So for example, if I told you to find questions. If I told you to find or convert 38 degrees Celsius, I said convert it to Kelvin. What do you do? Plus 273 is as simple as that. Simply add. Okay, so how do we do that? 30 plus this, 303 plus 8, 300, 8 plus 3, that's 11. 11 Kelvin. Do you understand? Alright, is there no calculator with you? Alright, let's go. Now, what if we wanted to convert that same guy, that same 38 degrees Celsius, we want to convert it to Fahrenheit? I've told you use the formula directly and you see how fast it is. Let me show you. So we want to go from degrees Celsius to Fahrenheit, degrees Celsius to Fahrenheit. So what do? We just say degree Fahrenheit will be equal to 9 over 5 times 38 plus 32. Alright, so we can now cut. We need the calculator. So we said what? So now give me 9 times 38. So what would that give you? 342 divided by 5. 68.4. Now add 32. 100.4. Now let me show you something. Let me show you how we came about that formula. The other way to solving this is this. You know this degree Celsius to Fahrenheit, right? So they use the same notation, upper fixed point, lower fixed point, right? Now I'm going to teach you about thermometry and how this thing is what we call upper fixed point, lower fixed point, and how thermometer even works. How do you think thermometer is able to check the temperature? It's just by expansion of the fluid. Do you understand? We've done another expansion of water before, right? Now, okay, I'm going to talk about it later. Let me just show you something here. Want to go from degree Celsius? What will be here for Celsius scale? 100. This will correspond to what on Fahrenheit scale? On the Fahrenheit scale, what was the upper fixed point? Yes, 212. Yes. How about this? 0 degree on Celsius scale, 32 degree. Is that okay? So what we want to know is that there is a particular point here where we measure on the Celsius scale, we measure 38 degree. What will be the corresponding Fahrenheit scale? Do you understand? So you now there's what we do here. That there's something mathematical that we do here. We take the ratio of these two, the difference between here and the difference between here. It should be equal to the ratio of the difference between here and the difference between here. Does that make sense? So see what I will do. 38 minus 0. 38 minus 0 over 100 minus 0 should be equal to x minus 32 over 212 minus 30. Does that make sense to you? Alright, let's go on. Now this minus 0 is 38. 38 over 100 is equal to x minus 32 over 212 minus 32, always 180. So cross multiply, right, from here. So we have 100 into bracket x minus 32, right, is equal to 38 times 180, give me that 6,840. We can divide both sides by 100 already from here. So we have x minus 32 is equal to divide both sides by 100. 0 cancels 0, move it. 68.4. Do you see now? 68.4. This guy goes there. X now equal to what? 68.4 plus 32. And what is that? 100.4. Degrees what? Where are we going to? Fahrenheit. Is it hard? At all, at all, at all. Do you understand now? Alright. Let's solve a second question. What if this other question says convert 142 degrees Fahrenheit, or let's go for Fahrenheit now. Let's say this one says, this is question 3. It says convert 183 or 188 degrees Fahrenheit to Celsius. To Celsius. How do we do this? Let's use this method again so that you master it. Is that okay? So we'll come here again. What is our upper fixed point? Now, the idea is the one you're looking for, try to put it here. Doesn't mean, but you can just try to put it here. Since it's Celsius you're looking for, and Fahrenheit is complete, come here. Fahrenheit here, 32, and somewhere around there will be what? 188. You know, I did not put it in the middle because I know 188 is close to 212. If you put it in the middle, it means you're saying it's around half of this. Right here, 100, here, 0 granite. Then you call this 32 degrees Fahrenheit corresponds to 0 degree Celsius. So 212 degrees Celsius Fahrenheit corresponds to 100 degrees Celsius. So 188 degrees Fahrenheit corresponds to x degrees Celsius. Is that okay? Let's take the ratio of their differences. So this and this, 188 minus 32 over 212 minus 1 minus 32. This minus this minus this. Do you get it? Is equal to that. I want you to master it. This minus this, x minus 0 over 100 minus 0. Alright. This will become, this minus this will be what? 2, 6, 5, 56, 156, right? Over, this minus is always 180. Is equal to x minus 0, x over what? Are you following me? Alright. So you cross multiply, you have 180x is equal to 15600, right? Divide both sides by, all x give me 1560 divided by 18. 560 divided by 18. It's 6.7 degrees Celsius. Is that okay? Well, let's see If we go by the formula directly, by this formula directly, let's see what we'll get. Okay, here we are now reversing it. Remember that in the reverse, from degree Fahrenheit to Celsius, we said it to be Fahrenheit minus 32 times 5 over 9. Is that okay? Everything. Now you're getting it right? Celsius, degree Celsius. Alright, so what's our Fahrenheit I was given? 188. So 188 minus 32 times 5 over 9. You see how easy this one is and cheaper. That will be 156 times, this minus this 156 now. Yeah, 156 times 5 over 9. Give me 156 times 5. 780. 86.7 degrees Celsius. Is it clear? Now, what if, let's have one last question. One last question. This one now tells you to go from degree Fahrenheit to Kelvin, or from Kelvin to degree Fahrenheit. No, let's do that one, from Kelvin to degree Fahrenheit. Let's say we had, it says, question 4 says, go from 386 Kelvin to degrees Fahrenheit. So what's the first thing you do? You convert to what? Celsius. So how do you convert Kelvin to Celsius? From Kelvin to Celsius, 386 exactly. Do you understand now? Is equal to what? 113. Right? That's it. Kelvin, right? Degree Celsius. So you now convert this to Fahrenheit scale. Of course, this one is already more than the Celsius this thing. But if you, so it means if you convert, the answer must be greater than, no. Here, you are converting now to Fahrenheit. So the answer must be greater than what? 212, because this one is greater than the Celsius scale. Does that mean? Okay, so let's solve one that goes from degree let's solve one that goes from degrees Fahrenheit or degrees Celsius. No, let's go from degree Fahrenheit to Kelvin. Is that okay? So, of course, we know from here we just add 273, right? In fact, that one is very simple too, isn't it? So let's say I had 98 degrees Celsius, 98 degrees Fahrenheit, 2 degrees Celsius. What would that be? I'll use the formula Fahrenheit minus my Fahrenheit scale value times 5 over 9, right? All of this is already what degree Celsius. To convert to Kelvin, okay, we are saying to Kelvin, right? So to convert to Kelvin, what do I do? Plus 273. Does that make sense to you? So this is the formula to go from degree Fahrenheit to what? Is it clear? Right. So here, this minus this, that is 98 minus 32 times 5 over 9. All of these represent degrees Celsius. My answer plus 273. Does that make sense? Okay. So from here, this minus this 66. 66 times 5 over 9. All of this will give me degrees Celsius plus 273. Now 66 times 5, that's 330. 330 over 9 plus 273. 383,110. 3 in 110. 110 divided by 3. Yes. 39.7 plus. Okay, all together. Plus 273. Okay, so that will be 309. It's not 319. 309.7 Kelvin. Is that clear? Alright, good. So that'll be it for this video. Do subscribe to the channel. God bless you. Now, should you shoot